I'm starting the live stream and I've remembered to unmute. Yes. Hi, I'm James. Oh, look, there it is. It's me testing out the command that says who I am. I'm James. I'm going to do some chill maths again. And I've got a problem that I'm going to work on. But otherwise, feel free to give suggestions in chat about what we should be doing. Hi, there's Joma. Hi, maths2222222. I've got a problem that I would like to show you, because a problem shared is now your problem as well. Hello, Mary. How are you doing? Hope everyone's okay at home. It is apparently already tea time, which luckily I have pre-made the cup of tea, so we're going to redeem that straight away. There we go. Thank you, Laz Joma. I have a mug of tea already. Tea time applies to all of us though, so that's your invitation to go and get a cup of tea just as we get started. And I'll tell you the problem in a minute or two, once we've got a cup of tea. Yeah, Mary, that's right. A cup of tea at the start now. It's a thing. It could be a thing, couldn't it? Right. Okay. If anyone's new, the idea is that we just sort of do some maths at the weekend together. It's not very serious. Okay. The problem is inspired by a cup of tea, actually. So good use of the cup of tea channel points thing. I'm going to try and draw the situation. It's about balancing. I'll try and draw. There we go. Let's do a circle, an ellipse like that for the top. And another one down here. This is going to be top quality. No excuses. We're going all in. This is the world's finest picture of a mug. Yeah, excellent stuff. Right, okay. And I need to kind of erase the back. Can I erase stuff in this? Learning to use Miro, the tool that I've been using forever. Can I delete part of it? No. Can I edit it? Is this like Inkscape? Can I do? Ooh, no. We started okay-ish. We started okay-ish. Don't. Let's not overstate it. Really thought one of these was delete like half the shape. Okay, never mind. We're gonna carry on. Ooh, would putting a large white rectangle fix that? Anyway, you've got a mug, which is going to be labelled mug, with a circular top. Which is like a ring. Right, it's not a filled-in circle. There's the inside of the circle. It's not there, so that the tea, you can drink the tea. It's important to distinguish between a circle and a disc, because what I would like is another one of these that's smaller, perhaps. And filled in. So let's fill this in a lovely orange colour or something. And let's give it some text. This is biscuit. Here's the scenario. You have, obviously, a mug of tea and a biscuit. Maybe the table you're a bit suspicious of, but the mug is clean. So what you want to do is you want to balance the biscuit on the edge of the mug, like this. So label here, balancing. So that I guess the centre of mass of the biscuit is somewhere where it won't fall into the mug. I'm not so worried. I don't think it's going to fall out of the mug. I guess it could. If you place the biscuit really badly, then it might fall off the edge. Should have brought a biscuit upstairs. Yeah. Okay. So there's sort of some range where, if you're training a robot or something to place this biscuit on top of the mug, if it gets it wrong, it's going to fall off outwards, and if it gets it wrong in the middle of the mug, it's going to fall into the tea. Terrible. The question is where? Where is safe to balance the biscuit on the edge of the mug? That's the whole question. It turns out to have a pretty straightforward answer, but then there's a variant of this question that I think is much harder. So we're going to try and do this and then maybe talk about the complicated one. Right. Oh gosh, what's going on in chat? Mugs without topology. Yeah. Not a topology stream. Sometimes when people tell you about a mug, you can go, oh, I know where this is going. There's going to be a donut in a second, isn't there? But no, today the snack of choice is a circular biscuit. Yes, Ice Rice Cooker Man. Today we're working on a problem to do with balancing things on other things. So this is my rather whimsical picture of what we're doing. We have large muggo, and I'm going to balance something on top. Let's do the top-down view. When I was at school, I did this subject where you would draw lots of pictures like that. Right, so that's too large. I sort of wanted this one to be the mug. Should we make the edge a bit thicker? Let's draw it like that, I think. And let's label it larger. I'm really learning to use this software after, what is it, years and years. And then another one, a circle for biscuits, which I guess I will colour in. No, I will colour in. Really learning. I watched a bit of Nstucky's stream last weekend. Nstucky's a viewer here who also streams, and their stream was quite different from this one. And we were talking in chat, and they described me as a variety streamer. So I guess that's what this is, variety. What subject was that? Oh, I did design technology. It was great. It was all drawing things in isometric view and drawing things in top-down view and thinking about 3D objects and trying to draw them, and then actually trying to make them in 3D space that we live in, like real stuff. Great fun. Would recommend. There's GCSE resistant materials, which just means physical stuff. It's great fun. The alternative was like electronics, which not as fun or whatever. Anyway, right, top-down view. So let's just quickly get some obvious cases out of the way. If the centre of the biscuit is so far away that none of the biscuit is touching the mug, then that's bad. And if, I guess, on the inside, if the centre of the biscuit is so close to the centre of the mug that none of it's overlapping, that's bad. It'll fall in. And there's an intermediate case where I guess we can talk about, is this going to be okay or not? Other ways we can make this problem simpler? Does anybody want to say in chat ways that they would, if you're trying to set up this problem to answer the question, where is it safe to balance the biscuit? Probably we should bring in some variables or something. Might get rid of these labels as well. Might change the opacity on this. It's now a see-through biscuit. I don't know what variety they are. But yeah. Look at the arc of the mug on the biscuit. Yeah, that seems nice. So now that it's translucent, you can see through to this arc of mug. And it feels like, if the centre of the biscuit, can I mark the centre? Let's just put like a full stop. Pretty close. If the centre of the biscuit, then move it down a little bit. If the centre is outside that arc, where it's covering, then I think that's bad, right? I think that's bad. Bonds, the labels. I'm going to put some more labels. This one already says full stop. That's kind of a better way of marking the centre as well. So if the centre, where it says biscuit, is outside the radius of this mug, I think that's bad news. If it's inside, I think that's good news. What's my logic here? Something like 3 points define a plane or something. No, that's not quite what I mean, is it? Because even when it's like this, there are 3 points defining a plane. It just happens that the centre of mass is nowhere near those 3 points of contact. Oh my goodness, there's a centered Unicode character, centered full stop. Goodness me. What will they come up with next? So there's some like circle geometry to do here, I think. which is why it's on this chill math stream, because circle geometry is one of the things that we can do. Without loss of generality, I think there's some rotational symmetry, right? That I might as well put the biscuit lined up with the mug like this. Which makes me think thoughts about solar eclipses. Yeah, let's put it there. Can I now shift it? Not quite. Control. Yeah, there we go. So you can imagine it coming in and saying, well, bad news, bad news, bad news, and then suddenly good news for a bit, and then bad news again. What's the crossover there where it becomes, it starts falling in? And if I'm thinking about looking at the arc of the thing inside there, I think it becomes a problem when the center moves. I'm almost there. You can maybe correct me in chat, but I think the problem is perhaps when that middle diameter crosses over, so that now there is some contact with the mug, but the center of mass is, how am I going to say this, outside of the convex hull of the contact. So convex hull is this word for you take an unusual set of points or something. The convex hull is the smallest region that contains all the points and is convex. It's sometimes the right answer for things where you mean kind of anything that's inside, but if the shape is weird like this, then you don't actually mean literally inside the shape, you mean inside the kind of region of the shape, the kind of convex extension of the shape. So I'm going to maybe never say convex hull again because I don't think I've explained it well, so I'll try and say it differently next time I want to say it. Is there a range of how far the biscuit can be on the mug? Yeah, I think so. I think it's going to be like a lower limit where you say, well, this is bad, it's falling into the tea. This is still quite bad because if it's just intersecting over here, it's going to topple inwards, because even though there's some intersection here, the center of mass is nowhere near that intersection. And then I get interested around here, I think, where the center of mass is now somewhere kind of inside this arc. By inside the arc, I mean join up the top and bottom to make this kind of curved region. Join up the top and bottom of that arc. Then the center of mass is inside there, and then I think it's safe. Yeah, so something like if there are. Part of this is to develop a theory of balancing, which we can then adapt to other shapes and stuff. Same to you. Part of it is to think about circle geometry. This way around, I think as soon as the center of mass goes over there, my intuition is that as soon as the center of mass is outside the circle, it's in bad times because you're not inside this kind of curved region of balancing. Yeah, so I'm thinking about drawing in. Now this is going to move, so this is going to be a little bit tricky. We might switch to Desmos in a second. I'm thinking about this region here, which is sort of contact patch and the kind of being somewhere inside in some sense. Strictly the inside of the contact patch is just the contact patch itself. It doesn't have an inside, it's just a bit of line. But I can join that up. If there are 3 points, if of contact, and yeah, okay, if you had 3 pegs or something, let's get rid of these lines. If you had 3 pegs, you're balancing a biscuit on 3 fingers or something, my incredible biscuit balancing trick, then I think you're good if the center of mass of the biscuit is somewhere inside that triangle. Because then it can't hinge around any of the edges of the triangle, or if you consider it hinging on an edge of the triangle, is it going to tilt off that way? Well, you'd say no, the center of mass is on the other side of that side. It's on the inside of the triangle. And similarly for the other edges, you would say, is it going to topple off that way? Well, no, the center of mass is on the safe side of that side as well. This edge of the triangle kind of has an inside bit, and then the infinite scariness of everything else, where if the center of mass is up there, it's going to topple that way. Okay, so if you've got 3 fingers,
you can balance the biscuit as long as the centre of mass is somewhere inside that triangle. And I guess your fingers have to be close enough together that the biscuit can, reach all three of them at the same time. I seem to have associated some of the finger with biscuits. Great stuff. Okay, if this was too far away, then you might say, "Oh, I can't get this to match up. Can't." If you hold your fingers too far apart, then you're no good. And something like that's going on here with the mug, right? I have loads of points of contact, I suppose, but the three most interesting ones are the furthest apart that are still touching the biscuit. Thinking about the mug as containing lots of fingers. I'll hold this digestive up, it'll be okay. Lots of fingers, but it's the outside ones that are most interesting to me. That'll give us a range then, and we've got some maths to do to work out where that range is. I think the critical case is where this centre of mass moves too far left so that this arc is somewhere on the right half of the circle. If the arc goes through the left half of the circle, then the centre of mass we're fine, provided we don't go outside. So it's quite a tight range here. I want this critical point, I think, is when this diameter, or what have I drawn? I've drawn a radius. This diameter, if that also lines up with exactly being where this circle is for the mug, then you get something like this. So time to give things names. I'm going to say that the mug has radius 1, and I'm going to say that the biscuit, how do you spell biscuit? There we go, has radius, what's a good letter? I'm going to go small r. I sort of already regret that. I'm going to go large R. There we go. Okay, so in here, large R for the radius, 1 for the mug. Maths fact, if you're setting things up for lengths, then you get to choose your own units. Physicists might choose to use sensible SI units, or even units in which maybe the speed of light is 1 or something. I have a choice, whereas for me it's the first length in the problem. Any other lengths can be letters, but the first one I might as well say it's 1. I suppose I'm proposing that we measure everything in the universe in terms of the radius of my mug, which, might as well. It's not going to be worse than inches, is it? We've got this critical distance over here then, which Pythagoras tells us is 1 minus r squared. Safe. So if, I don't know, this x position of the biscuit, so let's go x coordinate of the biscuit. In this case where it's on the x-axis, so I suppose maybe I mean radius if I'm rotating the picture around, but we'll come to that in a second. We want this to be, I'll think about the inequalities in a second, but I want it to be further right, not as far as that much, because that's the point where I think you start toppling outside. Not as far as that much, but please more than this much, so that the centre of mass is somewhere inside the region where the mug is underneath the biscuit. Should probably test this or something, shouldn't we? Has the Jamesometer come up? The Jamesometer. Sorry, the Jamesometer is something that you measure with. The Jamesometer is something that you use to measure other stuff as a unit. In a Matt live stream, wow. Professional James came up with that. What a weird contribution. Okay, special case then. Let's sense check this. If R is 1, this says anything goes, which sort of makes sense, I think. Let's just clone this down here. Oh, it's brought. I don't know how it decides which things are associated with the doodle. Maybe I had it selected or something, but the second one I do the washing up, clean this mug. Oops, too much.
Okay, equal size circles. So the claim is that, I think, anywhere you put this, if the same radius, it should balance, which seems plausible. That looks pretty good. There's all this intersection, all this kind of line where the circle is, centre of mass somewhere on the right. Yeah, it seems plausible, doesn't it? Centre of mass here. The mug kind of holds it all the way out to here, so it's not going to fall off that way. Close to the edge. Yeah, it seems quite comfortable, really, because the centre of mass is still on the left of this point. So I think if it's going to tip, then imagining a kind of axis right at the edge of the mug. Is it going to tip out of the mug? Not really, because the weight's on the left of the edge of the mug. So I'd be really surprised if this thing tipped out of the mug. And is it going to tip into the mug? Well, probably not, because it's touching the mug over here. Where's it going to pivot, right? That's a different way of saying it, isn't it? Where would it pivot? If it were going to fall into the mug, it would have to pivot around this line. Let's draw the line here. Why would it default to this? What even is this? Sort of line? No, I don't want to come around the line. My goodness, Myro. Behave. Straight line. Not connecting the word this to anything. No. Yes. Perfect. We got there. It would have to pivot around this line. Is that going to move? No. Okay. It would have to pivot around this line. That's it. Tipping into the mug. But the centre of mass is on this side, so that tipping motion would lift the centre of mass if it tried to pivot around that line to fall into the mug. And equally, if it tried to fall out of the mug by tipping around this point, then, well, that would also be lifting the centre of mass. There's kind of a left limit and a right limit. This is a bit like balancing a plank or something. Let's draw a side-on view of a different balancing situation that might be helpful. If you've got two supports for a very long plank of wood, there we go. Let's label this plank. Plank. If you've got two supports for a very long plank of wood, the rule is that you kind of want the centre of mass to be in between. If you put the centre of mass on the left, it'll tip. Hang on, planks are kind of wood coloured, aren't they? There's no brown option. Where's the brown? Right, we're going to have to add a custom colour. There we go. If you put the centre of mass on the left of the leftmost plank pivot point, it'll tip left. If you put the centre of mass on the right of the rightmost pivot point, it'll fall right. Anywhere in between is fine. And then the fun for this problem seems to be that as you move, not only are you moving the centre of mass, but also the geometry changes, so the pivot point moves as well. So you have this kind of extreme case where it just balances on the left pivot point. And as it moves, the pivot moves as well as this one moves. The pivot point moves as well because that's the leftmost intersection point under the plank. Centre of mass moves as well until it gets to the right pivot, at which point it just starts falling over the other way. Whee! Oh, I can rotate stuff. Brilliant. This is going to be excellent. What a great visualization. Right. Okay, we're balancing stuff. It's going well. The non-line. Yeah, Myra's quite keen on drawing no lines at all. Okay. Sanity check when R is very small. It's worth thinking about. If R is very much less than 1, then what? So then 1 minus R squared is almost the same thing as 1, which says that if you're trying to balance an M&M or something on the edge of a mug, you've got to be really near the edge of the mug, because that's, otherwise it will just fall in. So if you've got something really small, we can do better than that though. We can make this a kind of, we can do some sort of binomial expansion here, right? So this thing is approximately
1 minus 1/2 r squared, right? Like this, I think. Yeah, okay, so the kind of... Yeah, if r is bigger than 1, then I guess we have to start balancing the mug on. There's still a question there, actually, because you've still got to be... Well, you've just got to have the centre of mass anywhere inside the mug, sure. There's no danger of it falling in the mug, so the rule is now, like the plank again, just get the centre of mass somewhere over the mug and you'll be all right. And then you can turn the whole thing upside down, and now you have tea everywhere, but you have a new interesting problem to balance the upside down mug on the biscuit. Which is the same problem, I think. Yes, because they're both circles. Both circles at that moment. Right, here we go. Yeah. It's not just the convex hull though, because I shouldn't have said convex hull at all. Look, sorry. Because I've realised that if the convex hull involves points that are very far apart, then that's not safe balancing territory, is it? It's sort of like... Oh, I can fix that by saying what we're taking the convex hull of. If at some point the contact patch has a convex hull that includes the centre of mass, I think we're good enough. Yeah, okay. If it's big enough, you've got to reach. So my 3 balance point example up here is supposed to be that if these points are too far apart, then the convex hull of these points doesn't tell you. You also have to consider kind of intersection with a hypothetical biscuit. Fascinating. We could probably tighten that up a little bit as a definition of what balancing means, which would then properly convert this into a maths problem rather than some weird kind of physics thing. Anyway, I was about to balance a very small thing on the edge. There's this condition, I think, that says, approximately speaking, what you want is something like this. We're still using x coordinate. Maybe I mean r coordinate, which is why I stopped using small r, because maybe you want to use polar coordinates to talk about this problem and talk about small r instead of x coordinate. It's up to you. Convex hull of the intersection points. Yeah, I like that. What's a convex hull? Here we go. Okay, we're going to have another... I did a bad job of this, so I'm going to actually check what Wikipedia says. And then we're going to talk, see if that's what I mean or not. Smallest convex set that contains it. That's pretty good, isn't it? Oh, look, a green diagram. Is that going to be good? No. So a convex shape is one where for any 2 points, the line segment between them is also in the set. Any 2 points in the set, the line segment between them is in there too, which is true of some shapes, like regular polygons, but not true of other wonky shapes. Or if you take some random points in the plane like this, it's sort of not true that between 2 points the line segment is included. You can think about putting an elastic band around your points. So take a large elastic band around all your points and let it spring inwards towards all the points. It will be physics, it will be convex. It's not wrapping around the inside of any of that. Never mind. That's the right visualization. It's have an elastic band that closes in on your set until you get this convex hull. That's helpful for us because what we've actually got in our problem is something like a bit of a circle, and I want to say that this bit of mug edge is okay if the centre of mass is somewhere in here, but not somewhere over here. The distinction that I'm trying to draw is this kind of convex hull idea that good inside this kind of shape. We did it, it's chill physics. Welcome back. Yeah, may have said the word convex hull on the Matt live stream, not Matt live stream. May have said convex hull before. Sorry. This is weird to me. This looks like a radius of curvature kind of fact that I didn't see coming. Why is it half r squared? I was expecting it to be... Ah, no. Okay, so I was expecting this to be balancing a tiny M&M on the edge of a circle. I was expecting the result to be, from the point of view of a tiny M&M, the edge of the mug is straight, so you want the tiny M&M or something to be, only the radius matters. I was expecting it to be r or something. But of course, If the edge of the mug was just a straight line, then you can't balance an M&M on that unless you get it exactly right. Let's colour this one in red. Oh, it's not a circle. It's a... Silly me, that's not a real circle. That's a collection of points in the shape of a circle. Right. I seem to have committed to trying to draw things. M&Ms are like red, right? Let's put a black outline and I will get this. There we go. Okay, trying to balance a tiny M&M. I thought the answer would be, oh, you know, you get the radius about right, but that's not quite right. The fact is actually about r squared. The balancing is something to do with, you have to get this really correct. You have to get the center of mass in the right place to order r. That's not surprising. That just means that you aren't out by 3 times the radius or minus 2 times the radius or something. You have to get it right by a factor of r, but then surprisingly, perhaps, you have to get it right by a factor of r squared. Big R here is like the ratio of the radii. I think there's secretly a factor. I'm starting to regret calling it 1. There's secretly a factor of the radius of the mug inside that expression as well. Because this is a squared minus r squared in general. So if it's a, hang on a minute, just trying to generalise my maths, give me a second. If it's a in general for the radius of the mug, then this would be a, and this would wind up being, well, this would be a squared, sorry. This would be a squared, and then this would wind up being, you'd pull out a factor of a, and this would be r squared over a squared, but all multiplied by a, so it's a bit like saying this would be a as well. You have to be within a factor of r squared over a, it'd be multiplied. That was not worth doing, sorry. I'm erasing all of that, none of that happened. Variety. Okay, so these factors of like r squared make me think about radius of curvature, and what we're really saying is that this edge of the mug, even when you zoom in, looks slightly curved, just slightly. So if you zoom in on the edge of a circle, let's find a circle and zoom in. If you zoom in on the edge of a circle, then what you see when you've zoomed in is something a bit like a parabola. It's just a Taylor expansion fact, really. This thing kind of looks like a sideways parabola. Maybe I should zoom in on the lower side of a circle. There's one. So this kind of looks like a parabola if you zoom in down here. That's a Taylor series fact about the shape. And it's that curvature that has something to do with how you might manage to balance this to get the centre of mass very near the edge of the mug. Okay, rules for balancing things. It's hard to balance a small thing, not just because it's small, but by a kind of square factor of that. Okay, that's a lesson over here then. Lesson, balancing small objects is surprisingly hard. I guess surprisingly, your mileage may vary, the surprising for me. Okay. Factor of r squared instead of r. This is describing the kind of width of this safe region. I guess the safe region, because it's rotationally symmetric, the safe region runs all the way around the inside of the mug. It's kind of a golden zone where, depending on how big 1 minus r squared is, a safe region where if you get the centre of mass in that annulus, that ring around the inside of the mug, then you're good. But if you get too close to the middle, it just falls straight in. And if you get too close around the outside, if you move outside, it's bad. Okay, and that rate, the size of that annulus gets very small very quickly. If you make variable large r very small. Okay. What if it's very close to 1? Nah, same thing. Same thing, I think. You put an expansion in here. I don't think anyone really likes seeing the expansion, so I'm not going to do a second one. The important thing is I'm having fun. Anyway, I wanted to show you something about this, which is a second variant of the problem. Which is to imagine balancing a biscuit on a different shape, different calculation.
kind of really quite different maths. Let's give that a go. So what do I want? I want a copy of this biscuit, excellent. But I've got a very different object for balancing it on now. I would like some straight lines. Yeah, at a right angle corner. And I'd like them to be that type of line, thank you. This is now me just talking to my whiteboard. A cooperative relationship. You see, that time I did want it to match up with the edge, and it didn't like that. Like, that'll do. Okay. Can you at least like that? Can you join up? Oh, that's good enough. Okay. So I've got. You see how when I connected these things in Miro, it's drawn in this huge area. That's not a convex hull though. It should be drawing a big triangle. Why is it put this big rectangle? Anyway. Okay. So new scenario. I've got, I don't know what this is. The edge of help me out with the interpretation in chat. But this is two straight lines. We know that you can't really balance a biscuit on one straight line, a fence or something, because if you have it on this side, the center of gravity will cause it to tip inwards, and if you have the center of gravity on the other side, it will tip outwards. You have to get it exactly right, which feels unlikely that you could balance something perfectly on that edge. But we've got two of them meeting at a right angle. I don't really know how to describe this shape. I guess they're axes or something. But you've got these kind of interesting scenarios where will it balance if it's something like this? Will it balance over here? Will it balance if I do something like this? Where is it safe to put the biscuit so that it balances? It's still a biscuit. Maybe we could rephrase that. Chat, see if you can come up with a better interpretation of what this problem is. We're balancing something circular on a kind of, could that be like an open book or something? It could be an open book. It could be two walls, and this is. I do want it to be a circle, not a sphere, unfortunately. Tupperware in the freezer drawer, yeah. Anyway, pick yours at home. Something circular balancing on a corner. I could say it's a very large square object if that's nice, but I want it to be such a large square that we don't think about the other sides. There's kind of no way to interact with both sides. The biscuits turn out too small. I guess interesting question to think about what happens if it is a square, but I want to do this one first, where we have these two lines meeting at a corner. Right, okay, balancing Tupperware in a freezer drawer based on Herb's real life experience. I'm going to go walls. Maybe they're the walls, like the plastic walls of a freezer container for Herb. We're going to go wall. You've got a little garden. It's got these two walls that meet over here. Like they're very, very sharp walls. You've got to balance a biscuit on them. Very sharp, like knives. I don't know why you built such sharp walls, but here we are. It's snack time, so let's get balancing. So maths question then is, where can you put this such that the centre of mass is inside the convex hull of the intersection between the circle and the walls? Yeah, so we should draw the convex hull of the intersection points, which is much harder than it sounds, because, oh gosh, where are the intersection points? And maybe we can make our lives easier, but I'm not sure. We kind of want two things, right? We want kind of different ways I can see this going, where maybe you have a scenario like this where the origin of the axes or whatever, the point where your walls meet, is included, and you only get one point of intersection here and here. Or you can do this and get 2 points of intersection. Can I combine those ideas? No, they either both or neither, I think, because either the origin is included or excluded.
I guess I could have something like this where there are no points of intersection, but that's back to biscuit trying to balance it on one of your razor sharp walls, and that's no good. Okay. Yeah, like circular Tupperware lid or something. This one looks quite tempting to try and work with as a problem. I guess what we want here is to check whether this line. Oh, right. Can it do intersection points? A real test. That's good enough, actually, to check whether this line includes. Well, is the centre of mass on the safe side or the dangerous side? In this situation, it looks like the centre of mass is on the dangerous side, and it will pivot around that line and fall off. So I don't want that. Convex hull in this case, if you're playing along with convex hulls. Ooh, if you add holes to the biscuit. Oh my goodness, that was a terrible drawing of convex hull, but you get what I mean, right? It's trying to find these bits of intersection, and then the convex hull is like putting an elastic band around it to check, are you supported by this? I think convex hull is the right way of saying that. Are you supported by these random points? If you add holes to the biscuit, then topologically it becomes a mug. If you add holes, you can move the centre of mass around, is I think what Rice Cooker Man means. So the centre of mass is not in the middle anymore. In which case, yeah, you've got an interesting problem then, to say in general. Okay, also the holes in the biscuit will affect as well. The holes in the biscuit will affect where the contact patch is, if they're in unfortunate places. So it makes the problem much harder. So the previous one, if I just cut a hole in the middle of the biscuit, then that doesn't move the centre of mass. And actually it wouldn't change the answer for our previous question. Or maybe it would. No, I'm not sure it would. I don't think it would change the answer for our previous question. Maybe it would if the hole is large enough that... If the hole is large enough that... Yeah, okay, I kind of want to go back to the previous setup with a party ring, which is a circular biscuit with a circular hole in the middle, because that's not a centre of mass effect, that's a geometry effect. There are two things going on with Rice Cooker Man's suggestion to put holes in the biscuit. One of them moves the centre of mass if the holes are asymmetric, and the other changes where the points of contact are, because if there's a bit of biscuit missing, then that's not supportive. And if there's a weird shaped hole or something, then you can, fall where... Yeah, so that even if the centre of mass is inside something quite nice, if all of the points of contact... Yeah, it can fall around something, sure. That's already the case, I think. Maybe not. If the biscuit itself is not convex, then you get into this weird situation. Maybe you want to take the convex hull of both things, I don't know. Or take the convex hull of one thing and then intersect it with the other one and then take the convex hull of that. I don't know. Right, good question. Well done, Rice Cooker Man. That was great. What are we doing? Oh yes, balancing. So, Math222 in chat, I think, has had a go at this question and has reached a conclusion that it stays when the corner is inside the circle. At least maybe that's half a conclusion, maybe. Hello, Mean Machine Rex. How are you doing? We're trying to balance something on something else. Previously on the stream, we have fully analysed whether or not I can balance a circular digestive biscuit on the edge of a circular mug. Top side diagram, top down diagram. And you can, provided you get the centre of mass on the inside of the mug, but quite near the edge of the mug, in this kind of range. Hello, Fogel Stream as well. Hi. Ahoy. Are either of you live after this? I saw last week you were live. Fogel Stream was live just after us last week. Now, I could have done a raid, but I didn't know how to, or even that Fogel Stream was live. Fogel Stream's also a streamer. Centre is not outside the walls. Yeah, you don't want the centre outside the walls. So part 2 of this problem, having decided, fully analysing digestive biscuit balancing on a circular mug, we're sort of doing digestive biscuit balancing on a square mug, but square
it's tricky because there's lots of sides. So to start off with, we just have 2 of the sides. Oh, I'm sorry, you're not feeling well today. I hope you get better soon. Okay. Right. Let's do the problem. Right, okay. So, what's Maths Tutor 2 told us in chat? Something like, if this centre is in here, then you're good. Feels realistic to me. What maths did you do to prove that, though? How do you know that balances? Mean Machine Rex doesn't stream. Sorry. So I think for me, this is something like write down some coordinates and start saying the biscuit location is sort of center X, Y, and radius. And I think this time I'll make the radius of the biscuit 1. Previously it was the mug. Yeah, let's make the biscuit radius 1 this time, just to make sums easier. If you do that, then I think you can start writing down this kind of, well, kind of everything about the problem. I should not call it X, Y, because those are my coordinates. I'm going to call it A, B. Regret. A, B. Because then I can write down the equation of a circle, which is all I really want to do. And start finding out where these points are, right? For these intersection points. Because they happen when one of these is 0. But now we're getting geometry in chat. The corner is on the edge, the line is the diameter. Yeah, think about the critical case. Yeah, it sounds good. Ooh, angles, circle theorems. Yeah, okay, I've seen how to do this with circle theorems, which means I should do it with circle theorems. It's not how any of this works. Is this a circle theorem? Am I being stupid? I could just be being stupid. Wouldn't be the first time. Okay. This angle, if you come down from that point of intersection down to here, and then over to here, this angle has to be less than 90 degrees because, well, this line is coming back up again to get from this negative value all the way up again. So this angle has to be less than 90 degrees. That's, coincidentally, that's a way of detecting whether or not this line is left or right of the centre. I think this is what Maths Tutor 2 is saying in chat. Because the 90-degree case is Thales' theorem, the angle in a semicircle is 90 degrees. If that chord is, well, to the right, then this angle on the left becomes really small. This is silly, isn't it? The angle on the right is greater than 90 degrees. Angles in a cyclic quadrilateral. Great times. Okay. Yeah, I like that. Okay, so if you have the center inside the region of the biscuit, then there's an angle going on. The center must be reasonably close to this kind of triangle of security. Then you've got 3 support points, haven't you? You've got 3 support points, and the biscuit center of mass lies somewhere inside there by just triangle geometry, you know. We could demonstrate that this angle is less than 180 degrees, which is a test for this thing being on the side. This is 2 theta. Wait, this one's theta. It's less than 180 degrees on that side. That does look pretty good. Does that extend to tell you that it falls off on the other way around? Checks out with the things on my desk. Yes, you can do this, right? We could get like a bit of notebook to make a 90-degree angle or something. I guess now that we're thinking about angles, I should probably think about other angles, but a bit of notebook, something circular to balance on it. Oh my goodness, have I got props? Is this working? Working, right, 90-degree angle. I can't point the camera in the right direction, can I? Gravity is sadly working against me here. 90-degree angle, something circular to balance on it. The claim is, I think, that you can balance this on a 90-degree angle if the point where the walls meet is inside the circle or underneath the circle. Gravity, which I'm now going to test. that as soon as it moves outside, I've not got razor sharp walls with this notebook, but maybe you could try that at home. Can we do this with other angles? Oh, Mean Machine knows that thing about stacking blocks. I've heard that as a question to which, well, you've done the answer. So the question I've heard is something like, if you make a stack of bricks, you can put a little bit of overhang on each one, and the question is, how far can you go with the overhang before inevitably it will fall apart? And the surprising answer to Mean Machine Rex's question is the thing that Mean Machine Rex says in chat, which is that no, you can just keep going, which is super weird. You can keep going until you have a brick that itself is over the is not over the starting brick, which sounds just wrong, right? Like this brick is over here, it's not being supported by the lower brick directly, but the thing is that it is pretty close to the brick below, so it's not going to tip over that one. And the solution that I've seen has essentially so many bricks over here with centre of mass over to the left that it balances, because there's lots of counterweight that is over the lower thing. So it doesn't tip here either, because there are so many bricks over here that have centre of mass in a kind of nice grounded place, that one extra one up here doesn't matter. There's a solution that does this using, oh gosh, I think it might be exponentially many bricks to get an overhang of distance d, so an e to the d with some numbers in there as well. It's a thing to look up. It's good. What would I look up? Something like balancing bricks, infinite overhang. That's probably what I put in Google. Right, I'm just gonna move all of that discussion over there. Okay, think that I wanted, what else did I want to do with this? I wanted to check that if you move it so the centre's not included, then it will tip over. I'm not sure if that's obvious. It's maybe obvious to some people watching at home, but it's not obvious to me. So I think I'm going to do that case. This is the case where you get two roots. You get, in each case, you get 2 points here and 2 points here. And I think this is not good enough. How obvious is this? So the centre of the biscuit is at the kind of midpoint of these things. And the question is whether this line that joins these is on the kind of far side of the centre of mass. Yeah, I think it's not. Math Teacher 2 is saying angles, and so is Mean Machine Rex, which means that maybe this is obvious and it's just angles. Is it obvious because angles? Give me a second. Like a lot of things in life. Oh, right, okay. You've got to draw in the correct triangle and then it's okay. Line, line, line. What's that angle? That angle is less than 90. And that means that this is kind of left of the diameter. Sorry, that angle's greater than 90, so this line is kind of left of the diameter. Should we try and write up this fact that we're using? Yeah, if you can't suspend the diameter of the circle... The diameter has been relevant in both the cases we've seen so far. Yeah. The diameter is an interesting pivot, I suppose, because the centre of mass definitely lies on the diameter, whichever diameter we're talking about. And if that line, gosh, hang on. If all of your intersection points are on the same side of some diameter, so if you have some setup where you have a biscuit circle, and all of the intersections, some complicated scenario where you have all of the intersection points, but they all lie on the same side of this diameter, then bad news, you're going to tip the other way. Yeah, change the average density. So that's this separate thing. General angle. General angle. Feels like we are doing general angle.
Yeah, okay, we'll do general angle. Let's do general angle. Have you already done general angle in chat? Is this a thing that you think I can do in the next 5 minutes before we take a 3 o'clock break? Or is this just... Am I doomed? Am I doomed? I think I'm going to have to do it with circle geometry. I'm going to have to use all of the skills that I've learned so far, like a kind of final boss fight, where you use everything you've learned all at once. General angle. This looks impossible. This looks absolutely crazy. And that is not making it better. What was the rule there before? So that looks quite stable actually, even though it doesn't include the center. So I think it's not the same solution anymore. Including the center looks gorgeous. Like really good with this small angle. 3 o'clock, T o'clock, yeah. And actually it looks like you can get away with this sort of thing as well, where... what's this? So I'm interested in this line for these intersection points. And it looks like it goes wrong if that line passes through the diameter. So what is the set of points? What is the set of points where the diameter passes through? Oh my goodness, this is a very tricky question, isn't it? This looks really hard. Out the other side. So for a very small angle, you're almost always good, and until you get far enough away from the point where the two lines get too far apart. What am I going to do? So I'm interested in this line. I'm just not convinced I can solve for the positions of any of these things. Ooh. Let's scribble on it and see what we can draw. Okay, so we've got these intersection points. These ones feel relevant. They were relevant before. I'm interested in whether this line is on the left or right of the centre of mass. In looking at it, left, right. What does left and right mean, or something? Is it on the pointy end or the infinite end of this? Yeah, something about angles being greater than 90 degrees, right? I'm not sure where I'm drawing these points though, so like this angle is an obvious one to draw in, I suppose. But this one... Okay, so then the critical points, the ones where I'm getting really nervous, are the ones where... Yeah, the ones where this is actually 90 degrees for an angle in a semicircle. Where this line, you're like, oh my goodness, it's right on the critical pivot line, the centre of mass is right there. If that's the case, then this is a right angle, which feels powerful somehow, that we might be able to say something about triangles. So the centre of mass is on this line, so critical case, where it's just balancing. The centre of mass is on this line. There's a right angle over here, also a right angle down here, but feels like I should just label some Pythagoras stuff. So this is one. I don't know where these intersection points are. I could solve for them, I guess. I don't really want to. Yeah, something like I want... Is this easy? No, this is not easy. I want that to be a right angle as well, which lines up nicely with my coordinate system. So maybe I want that. Yeah, so this one I know 2 things about it or something. Something like that. Get 2 solutions. One down here, one up there. Yeah, okay, so I've got points where y is 0, and I want the left one of those to line up perfectly with a point that's on that line and the circle. Sounds like some geometry to me. Sounds like some algebra. People in chat are dunking on custard creams.
Oh no, they are dunking custard creams. So sorry. There's a thing you can do with biscuits. Oh, we've hit 3 o'clock. You can't redeem it. Oh, because it's already been redeemed. No, right, hang on. Let's. Yeah, okay. What is this? So Twitch is telling me my stream anniversary is coming up in 2 days, which I don't think is true. I think I started streaming September, but whatever. Okay. Apparently we've been streaming for a year. Thank you, Twitch. How do I undo the thing? How often are you allowed to tell me to drink tea? Let's see. What's it capped at? The cooldown is 30 minutes, I think. Which is also the cooldown time for a cup of tea. So, makes sense. Yeah, I've no idea why you can't redeem it. Right, turn off the cooldown. What's the worst that could happen? What's the worst that could happen? That's what could happen, isn't it? Mini jammy dodges are a bit dangerous, aren't they? Okay, so plan very quickly before I take the cup of tea. That's gone cold. That's no good. I'm going to write down the algebra for what I'm doing, which is just this. Then take lower root, plug in to equation of circle, and also y equals tan theta x. Did I say this is called theta now? Y is tan theta x. Solve. And that will give me the y coordinate, and then something like, then use the fact, something like, maybe use the fact that y squared. Pythagoras? No, don't love this. Tea time, I think. Drinking a cup of tea also helps give me good ideas about how to solve problems. So we'll see if that works. I will see you in a couple of minutes. I'm also going to run an ad break because I can, and because the ads, in some sense, support charity. Right, good. Nothing's going to happen here while you're watching ads. I will see you in a couple of minutes. Tea time works. Yes. Tea always works. Right. 2 o'clock, 3 o'clock. See you in a couple of minutes. Bye. I'm back, but I didn't have any ideas, or sort of like draw some more lines. Oh, then I came back and I sat down and I saw this. Oh, look at all that. What are we doing? 5 ads is too many. What's the usual amount for Mary? Sorry about that. Right, good. Did we get more than 10 people? Yeah, we sometimes gain viewers by running ads. It's sort of a weird Twitch thing, I think. If you run ads, then Twitch maybe tries to pack people. I don't know. If you've just joined us and seen some ads, then hi, welcome to the stream. We're doing some horrible circle geometry for some reason. Struggled to remember why. I just wanted to make a cup of tea and came back and saw what on earth I was doing. Have I seen Hogseyes Wave in person? Yeah, I saw it in the British Museum. It was great. The rule was that I was only allowed to buy one thing from the gift shop, because there's a dangerous situation there that I might go to the gift shop and get everything. So the rule was I was only allowed to get one thing from the gift shop. I came away with 2 things from the gift shop, and since then, I've been slowly acquiring all of the other things from the Great Wave gift shop one by one. They're selling Great Wave travel mug and stuff in other shops around the place. Ha 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 ha. Trying to catch them all, where all of them is this one specific thing. Yes, good, right, okay. All waves, 100%. Yes, would recommend. It is a good bit of art, and the story there is that it was mass produced from the get-go. The fun of having lots of cheaply made things to have the Great Wave in is that kind of also that's what the Great Wave is, that it was mass produced immediately, it was the idea, and not expensive when it was produced. So I'm embracing the spirit of that by getting lots of items that have the Great Wave on. Right, that's my quest. I haven't got anything to show you. No, it's not very wavy in here right now. That's a shame. There's just like the one behind me and the one I'm wearing. That's all. Right, we're doing geometry. Let's not get out of it by talking about the Great Wave. Right, okay. Twitch has got good news about September. Yeah, I once tried to count and it was, a bit scary. Yeah. My obsession with the artwork started when I needed a poster for a wall. I had a gap on a wall. There's one wall I was allowed to put a poster on. I think it had pinboard or something on it. I wanted to put a big poster on, and I bought a very cheap poster that was the Great Wave, and that's followed me around forever. Oh, and then I did a PhD on fluid dynamics. That kind of helped a bit in terms of appreciating the Great Wave. There is a copy of the Great Wave in my thesis. Right. Hi, and Stucky, how are you doing? Good afternoon, good morning, good evening, good night. We've got a circular problem here. I'm worried that my logic might have got a bit circular. Let's do the setup, just in case people have joined us. And also because I want an excuse to erase all of this nonsense. We're balancing things, mostly at the moment biscuits. We started with balancing a biscuit on a mug. We're now balancing a biscuit on this kind of pair of lines. The rule is that if the centre of mass is supported by those bits where the biscuit is on the supports, supported by here means something like it's inside the convex hull of those points where it's touching, then it's balanced. We'd like to know where to put it that works out. Yeah, Stucky's here. Is this when the perpendiculars are inside? Which perpendiculars do you mean? Ooh, is it these ones? No, I was going to draw in some lines that weren't even perpendicular there. You're going to have to help me out. And Stucky, are you live today? You were live last week. I'm trying to learn people's schedules. Last week, Stucky taught me the concept of a raid. Oh, goodness knows. I guess you're not live right now because you're in my chat. I can work this out. This is the problem. I can't coordinate a raid with somebody who's how do people do it? How do they do it? Am I supposed to go on Twitch now? You're going live though. Okay. Right. Look at this. This is how we coordinate it. How do we do the handover? So the handover would be when I inevitably stop streaming, that we might point people towards nstucky, but I don't know if the timings work out. We'll see. I could just do it manually, right? Look, nstucky does math stuff on Twitch. They're in chat. You can use Twitch. Yeah, who knows? Also, have I even got the buttons? Oh, now I'm panicking that I might not actually know what I'm doing. Oh my goodness. Yeah, one day we will work this out. Is it now? Right, okay. Twitch another time. Yeah, let's do that. Is that a thing I can do? Oh, look at it. Now you get a link. We did it. Oh, it didn't turn up on that box, but it is on the Twitch. There's so many ways of splitting hairs on things, right? Like the Twitch alerts box is different from the one that appears in chat, which is different from the one that appears in the dashboard. But all of these things are sort of similar. So whichever way you're looking, you might see the Twitch alert in the right place. Oh, it's got a timer on it as well. Everything in Twitch has a timer. If you're on an ad break, it slots 3 different timers. I say this a lot as a way of getting out of doing my homework, which here is to think about. So this is 2 points. The distance to the centre of the biscuit labelled incorrectly, but the distance to the centre is 1. And you can ask about the angle there. You can ask about whether it's a straight line or not. It feels like it should be related to this angle theta, but I haven't got it. Need someone else to start. Need a TA. Yep, good. Label the points. Okay, let's label the points. I feel like we might be getting somewhere. Okay, so let's actually try solving some stuff. Let's try just brute force, work out where all of these points are using maths. Well, at least these two, where y is 0. So y is 0 gives me something like x minus a squared plus is 1 minus b squared. So then x is a plus or minus root 1 minus b squared, which is not too bad. Oh, there's a quadratic equation hiding in here, isn't there? I've seen that before somewhere. Anyway, in the critical case, I'm going to follow these lines, I think. That lower one is also the x-coordinate of something up here. So take the lower one. Oh, you label them A, B, C, D. Oh, okay, fine. Okay. A, B, C, and D. Do you want to refer to them in chat? Yeah, I use my H too much, Mary. I'm trying not to. Technology best procrastination. Look, I can now read out chat messages instead of thinking. Right, okay, so that's the x-coordinate of A. It's A minus something. And I'm interested a bit in whether that's left or right of D. Am I really? D is also where it intersects with, so this line is y as tan theta x by trigonometry rules. I'm really struggling with this. It is just going to turn out to be something nice involving theta, like 90 minus theta or something, in some sense. But goodness me, I cannot see how that's going to work out. So yeah, okay. If this is, right, hang on, we can do this. B onto CD. Yeah, okay. So you're talking about B onto CD, and I'm thinking about projecting D down to AB to think about where those points are. Because if D is to the left of A, then this triangle has a large angle here, which makes me start to think that the centre of mass is too far away. So I think I can just find, this is the x-coordinate of A. And I also want the x-coordinate of D, which is slightly harder, but not impossible. Not impossible. Let's go. You heard it here first, not impossible. So it's something like I need to solve this plus x tan theta minus b squared is 1, which is going to give me some not very pleasant. Oh, I know this expression. I've got a rule for that. Minus 2ax minus 2b tan theta x.
is, oh my goodness, 1 minus a squared minus b squared. I'm going slightly too fast, but there's an x in here. Quadratic, write down a sec squared. Hello, R4981. I like your username with its square numbers. It's pretty good. Welcome to chat. We're doing some algebra and geometry based on a silly idea about whether you could balance a biscuit on a pair of lines. It's to do with whether the centre of mass is inside or outside a particular region. So I'm going to get some inequalities going in a second. But I think my critical point then is whether or not... Yeah, so critical if XA satisfies this. So that's the kind of critical point, and then we'll do something sensible to think about which side we want. First, that 1 plus tan squared is sec squared. So, and this, it's not very nice, is it? 2ax, 2b tan theta. Let's do this. I want to take the 2 out as well. A plus b tan theta x. Sorry for the terrible nature of what I'm doing here. Got to mechanics. I sort of just want to plug in XA and see if it does it. See if it does it, but that's a bit mad because, I mean, look. I should plug in XA into that equation, not into this one. This one's been all multiplied out. Horrible. I should plug in XA up here. Yeah. Newton. Love Newton. I should have a picture of Newton. Just like on the desk. That'd be good. Just like, what would Newton say in this situation? Yeah, XA satisfies this nicer equation that XA minus A squared is 1 minus B squared. Right, so, or alternatively, you can ask whether this is true. And then the ones cancel. Oh, and the b squared moves over. It's going to be so good. This is much better. Forget that. So plugging in XA up into this version of the equation, which is a statement about where D is intersecting the line and the circle, the ones cancel and the b's move over. Right, so now I need to think about whether this is true or not. So is this true? Either XA tan theta is 0, which looks implausible, or XA tan theta is, if this is a plus sign over here, then you get 2b. I have an expression for XA, so I think we're there. I think the question is just, it's critical if where A and B are the coordinates of the centre of the biscuit, whether or not this thing is implicit equation relating together A's and B's for the kind of interface between these things. Let's Desmos that and see if it's at all plausible. So these are like X and Y coordinates of biscuit relation. I'm pleased with that. We're going to try and Desmos it. The trick to put the critical point in earlier was, I think, a successful one. Right, okay. Desmos is up and running. Oh, it's going to be all in the same place for a second here. There we go, that's going over there, that's going in here, so that I can read and write at the same time, look, and read Twitch, and notifications and timers. Everything all at once. Right, here we go. There's probably a nicer way to rearrange this, but I'm so excited about the expression that I'm just going to go for it. So we're going to need some letters here, aren't we? We're going to need to tell it what tan theta is. I think in Desmos theta might be sort of reserved for angle, so I'm going to go for P as my angle, which is not very good, is it? But never mind. Let's slide that. Oh, that's terrible, isn't it? Let's make P something nicer like pi by 3. Yeah, it's an unmitigated disaster. What is that supposed to be? What is this? Awful, it's so bad it's off screen. It's drawn me this. It's not what I wanted at all. That is not a good line of criticality, because, you know, I was hoping that it would be something to do with this.
P was one of the worst letters I could have chosen. I guess I picked it because it looked like phi. I was hoping it would curve the other way. Give me a much nicer expression. Have I missed a minus sign or something? Yeah, this has gone terribly wrong. Don't worry, we're going to fix it. Fixing your work is a kind of key skill, I suppose. What have I done wrong now? So I found this coordinate, xa. I asked whether it was the same as the x coordinate of d. Thinking left-right kind of support, 90 degree idea. Seems plausible. Yeah, with a kind of balance point where it's equal. So that's not been a success so far, but maybe I've just missed a letter somewhere. So when y is 0 to find a, I found this b squared, I subtracted b squared. We looked at that, we got the plus or minus sign. That looks quite good. Yeah, I chose the smaller one. That was good. Yeah, we can't see, sorry. I've caught up with chat as well now. I was looking at too many things at once. I have a little bit of screen where chat is. Well, I have two. Never mind. Let's not explain it. It's not interesting. X tan theta minus b. So all of that. So the circle and the line at the same time. And then I thought I'd successfully. Oh no, I thought I'd successfully avoided multiplying that out by just plugging in xa in here. So is it the square root? No, the square root looks okay. Goodness me, what have I done? What have I done? What have I done? Tan theta is 2b. Do I mean 2b? Yeah, I think I mean 2b. Because then xa tan theta opposite over adjacent will be up there somewhere as the y coordinate. That's what I want to do. I want the y coordinate to be all okay. Yeah, okay, if I typed it wrong in Desmos, it's entirely possible. X minus y, where I'm using x and y because I wanted to show me locations of the center of the biscuit. And it's not what I expected or wanted at all. Sanity check then. So if you're somewhere on this curve, like 1.34, 0.36 or something, what are all of the variables? Animate slide fp from 0 to pi. Yeah, well, I think it's just going to be bad. Not optimistic. I think we may have tried something to... Yeah, it's not good. Oh, it gets it right for pi by 2, I think, because quarter circle is the right answer for pi by 2. So maybe I'm just asking the wrong question. Asking the wrong question. Not even symmetric, left, right. Look. You know, not left, right. I mean above and below the pair of lines. I think I'm asking the wrong question, which is annoying that this plan just before the tea break at 3 might not be very good. On the other hand, I've got a cup of tea now. How did this start? We started by balancing circles on top of a mug, with the idea that you have a circle to balance on top of a mug, and if you put it right in the middle, terrible news. If you put it on the outside, but on further with the centre further out, it'll fall over. In between, it's kind of a sweet spot. Now extended to be, instead of a round mug, a angular mug. Can I draw the edges in Desmos? I guess so. So let's choose a point on that curve. How do I choose a point on that curve? Look what you made me do. Can I draw any edges? So these two lines were supposed to be edges, I think. If I make them black and thicker. So that in particular, it's this case, this point here, where 1, 0, which I just don't think should be on the curve. Why is 1, 0 on the curve? For any value of theta, 1, 0 is on the curve. Look, because this will be 1 minus 1 and this will be 0. So let's try and draw the case where we're at 1, 0. That seems to be accepted by my maths, but I'm not very happy about it. Orange biscuit. I'm not very happy about this, because look, the x-coordinate of the intersection is 0. XA should be 0. Yes, it is. Oh, and then D. Ah, we've got some cases where it's on. Some cases where it's here, but then so I've checked that point of intersection XA does line up with, oh dear, in this case, in this very special case, it's lined up with the left root. Is that the problem? It's lined up with the left bit, not the right bit. So we've got this case. That sounds like balancing to me, but maybe it's not the critical point of balancing. So I kind of can't distinguish between C and D in my method here with my big plan to get A and D to line up vertically. Can't distinguish between the two. That's quite bad. Can I choose a point over here somewhere? Like 1 point, let's go for 1.2 to 0.31. I'll say now this is terrible, right? That does intersect. And the left one, the left one's still lining up with the left root, 0.26, 0.267-ish. 2.69, I didn't quite type that exactly right, did I? Okay, so it's, at the moment, I think always showing me bits where the left root lines up with the left intersection, which is not always the case. If I throw this to a different point, I can imagine it having coordinate intersections over here and down here. Yeah, I think these at the moment, I think these are good. I just don't think we're on the kind of edge of the world, right? I don't think they're on the point of falling in, which is what I was trying to do. Yeah, okay, so I think I've just missed a minus sign somewhere, or failed to allow for a minus sign, which is kind of less forgivable, but still. So checking that it's on the circle, but that could be C. How do I make it D? I make sure it's the larger solution of that quadratic. Bother, maybe I need to go back to that quadratic, write down the other solution. Well, I don't particularly want to, but sometimes you've just got to bite the bullet, haven't you? Multiply through by cos squared? Is that clever or just silly? Let's just try it. Let's just write down the solution to this quadratic equation. So there's this version of the quadratic formula when you have a number, the number 2 in the middle coefficient, which is slightly better. In this case, it's nice anyway because we have this minus sign around here as well. So we've got these two roots. I'm going to try writing out a more complicated expression that should give basically the same thing, but might make it more clear where my issue of distinguishing between C and D has gone wrong. Oh my goodness, I don't like this at all. Wow, nice, love it. Moving the a squared plus b squared minus 1 on the left, but remembering the minus sign in minus 4ac and divided by, and we're not doing the 4 because I used the number version with this thing in here, because now I'm going to divide by sec squared. Good, right, remembering all of my quadratic equation training. No 4, thank you, if I'm doing the version without a 4. It's like cancelling the 2. There's a 2 here, and a 4 here, and a 4 here, and a 2 downstairs, and they all cancel. Provided you remember not to write any of them, then you can get away with not writing any of them. Okay, so I kind of just want the larger root here. We want x plus to be the same thing that we wrote down before, which I think was a minus root 1 minus b squared. So maybe I should just write out that. Don't like it. It's not exactly incredible amount of understanding that's going to go into this expression, is it? But I think it feels a bit more watertight. Okay, we'll do this and then we'll simplify it. We should simplify it first, shouldn't we? A plus b tan theta plus root a plus b tan theta squared minus... It's very tempting when this this has sort of clearly become too complicated to be interesting or nice at the end. It sort of stopped being good TV quite a while ago. I've now got to the point where I've become slightly bloody minded about it, and I just want to see it through to try and fix the thing that I think is broken. This is no longer a kind of happy story, is it? Oh dear. It's a real sort of vengeance thing. Deary me. There's not much demand for vengeance maths. Nobody wants to see that on Twitch, but here we are. Right, we're going to type all of that into Desmos. That'll do it. It's like 0% chance that that'll do it. Right, we got grit, yes. A mean machine has told me that I have grit. I'm going to give that a go. That's, for streaming reasons, make that nice and large. For, you know, getting the right answer, we want anything but, right? Nice and small, and then no one will see if I've got the right answer or not, so I could just move on. Right, okay, I'm going to copy this out, but I'm going to type X every time I see an A. I'm going to type Y every time I see a B, and I'm going to type P every time I see a theta. What could go wrong? What could go wrong? Square roots are still square roots, though. This is the same thing that I already typed. Let's square, that's how the quadratic formula goes. Minus, and then amazingly, there is this thing squared. And then there's some more A's and B's inside this formula, which I don't love, but here we are. This thing seems to be detecting x squared plus y squared minus 1 is detecting whether the centre is inside the circle or not, which I should probably be thinking about that, shouldn't I? On the right, it's slightly worse. Or is it? So I want this a minus squared or minus b squared. And not a's, x's and y's. Oh, this is good, isn't it? And that's sort of worse. That's sort of worse. That the curve that we had before, plus a little extra bit of curve over there. Oh, that's a disaster. Yeah, so we've rediscovered the same thing. In the same colour. Plus, well, who knows what that is down there. Plus or minus. Let's do plus minus and see if that fixes things. Not really. Let's draw a semicircle. Let's draw half a circle as well. So, good times. Right. I think that's a sign that we switch. Do we switch topic or do we switch geometric approach? Quick vote. Quick vote in chat. You can do additional votes if you spend your zero-dimensional channel points. Reminder: channel points are made up. They're not worth any money. They are zero-dimensional. And there is a poll to vote in chat for whether we are doing this again using maybe different maths or just like ditch it and do something different. And it is currently 2-1, but some people have got lots of channel points, so it's a way to sort of change your. It's a way to use your channel points if you want to. There is, as far as I can tell, no mechanism, and Stucky can correct me if I'm wrong, but there's no mechanism for me to know how many channel points people have got and what they might get up to with those. Mary's used all their channel points on telling us to drink tea, so I hope people watching at home have got a cup of tea as well. And pre-roll ads have started because we hit the half-hour point. Voted twice. Right, okay, trying again is winning. Not unanimous, but trying again. So, let's see if we can get that to happen. Trying again. 4 times. So the vote is 7-1, but maths. I get a little pop-up to tell me that Maths Tutor 2 voted 4 times. A bit rigged, isn't it? It's kind of a bit always designed to be rigged, which I'm leaning into because I think that's funny. Right. Okay, we're copying this down here. Our question is still, will this balance? And I like most of this, right? I like most of this as an algebraic setup. I think... When is the perpendicular on the circle? Which perpendicular? Which one are we drawing? Well, the midpoint of AB feels relevant. The midpoint of AB lines up with the A coordinate, the A plus or minus something. So there are two cases where the centre lies to the left of this, which feels like some sort of fact going on. You've spent 33,000 channel points on tea breaks, which we do every week. So that is commitment to the course of making sure we take a break at 3 o'clock. That is amazing. I think I upped it at one point, so oops. Yeah, so we've been talking about when does D have the same X value as A, but that didn't feel very successful. You can always draw this triangle. Draw these. You need this for the kind of support points on both walls. Yeah, I want to say thank you, Mary. And the question is just, is that angle from D to A larger than D to B? Ooh, is that larger than 180 degrees or less than 180 degrees? Indicating that the centre might be over there somewhere or not. And hang on, can't I do some of the angles? Some of the angles here are just trigonometry facts, right? Like, oh no, this is not. It's not a cyclic quadrilateral or something. There are some angles that we know. For example, if I drop these perpendiculars that I think Maths Tutor 2 wants me to drop, then I've got a cyclic quadrilateral, and then I can start talking about that angle. And then a little bit more that comes from these. A little bit more that comes from those. And that might be a way to talk about this angle over this side. To talk about whether it's greater than or smaller than 180 degrees. Could work, couldn't it? Talk about, I'm imagining these triangles kind of flexing as the biscuit moves around and these contact points move. You get these isosceles triangles. They don't look very isosceles in my picture, do they? But you get these isosceles triangles perpendicular, and you can start talking about angles. Start talking about the angles there. With the critical case being where those two small angles that I've marked in, phi 1 and phi 2 or something, if they bring this up to a 180 degree angle on the right, then we're just balanced, kind of criticality. That's a different way of saying this kind of critical thing that's been repeatedly turning up. On the other side, around here, what with these right angles going on and stuff, I think you have 180 minus theta, pi minus theta for those who use radians, which should be me really, but force of habit at this point. Okay, so if theta 1 plus theta 2 is greater than theta, then you're okay. Because these angles will be so large that the centre of mass must be over on this side. Can it ever get over here? Probably not. I'll worry about that in a second. Okay, so theta's fixed. I need to talk about phi 1 and phi 2. This is different from balancing a pen on a fingertip. One side is stable. Yeah, it's like having two fingers and balancing a pen on two fingers. There's a region where it's okay. And here, as you move, also the points of contact move because they're geometrically defined as being the intersection between the circle and the lines. So it's complicated because they're moving and you want to know where the things in between. Right, okay. I know things about phi 1. For example, I know this y coordinate is b, and I know that the radius here is 1. So phi 1 is arccos of b. Is phi 2 something similar? If so, then I'm sort of done. I don't think it is very similar, but you know, it's worth thinking about. How would I do something similar? I would find, if I could find this distance from AB to the line, then I'd be very happy because I'd have a distance. I could write down an arccos fact. Jason overpipe wasn't used. Yep, I could write down an arccos fact and be done with this, I think. So, question, what is the distance from AB to the line y is tan theta x? That's not impossible. That's quite doable, I think. It's not going to be a pleasant answer, is it? But I think we can make that work. I can't remember the formula for this. Distance between a line and a point. So I'm going to have to improvise a little bit, which won't be very fun, but you know, I'm going to stop writing tan theta and start writing m for a little bit. Oh, I'm off screen. Where's the edge gone? There's the edge. I'm going to start writing m, and I'm going to do some coordinate geometry. Let's go. So that perpendicular, the one that Maths Tutor 2 is, I think, always telling me to draw, is something like y is minus 1 over m, x minus a plus b. This one up here, let's label it with some sort of colour. Violet dashed line. That one is at right angles to y equals mx, tan theta x, but I can't be bothered to write tan theta. And it goes through AB, so it's this, and that meets y equals mx when, and then I think there's a formula book kind of approach to this where you just look up the distance from a line to the point, but it's not one of those streams for me today, so I'm not going to push my luck. Oh my goodness, what if I multiply by minus m? Brave. Minus m, why did I do that? There was a minus sign in here, and I wanted to bring it up to over here, and okay, fine, I've brought in a minus bm. Sometimes I think I am doing this way too fast, but never mind. So then the x coordinate is something like this. A plus bm and a 1 plus m squared over here. I may accidentally derive this. Yeah, I think I'm getting there. I think I'm getting there. I might go and check afterwards. The y coordinate is that multiplied by m. The distance is then something like, so the distance squared is the difference in the x coordinates squared plus the difference in the y coordinates squared, and that's the distance that I want with m tan theta, and maybe this simplifies a little bit. Yeah, that minus a is going to be very well behaved, isn't it? This is going to end up being bm minus am squared over 1 plus m squared, all squared, which is not too bad, all things considered. And this is going to be very well behaved as well, I think. Close enough. It's going to cancel off ma. I get a bm squared, but then I'm subtracting some terms. If I bring this into a fraction like this, that's not too bad at all. Oh yeah, this simplifies way more. I'm getting there. I can bring out the factor of m from this. Oh yeah, okay, we're going to keep going. Bring out factor of m from this to get b minus am squared, and that's also b minus am squared, and it's both of them are over 1 plus m squared, but that's a factor of m squared plus 1 on the top, so this is just b minus am squared divided by 1 plus m squared, or something. For the distance, should probably check that. Should maybe have done some geometry on that, right? You know the coordinates, know the coordinates for this point. Yeah, never mind. Should maybe have done some geometry. Who needs geometry when you've got 10 lines of algebra? You're doing things the long way. 15 minutes on the clock. Okay, I think that's the distance. So then I want arc cos of that as well. Let's test this on some lines. Don't sound very confident, do I? If b is equal to am, this is 0, which is quite nice. If m is equal to 0, this is just b squared, because you're looking at the square distance down. And if m is infinitely large, this thing looks like a squared, which is a good limit over that side, because that's the difference in x coordinates, point to a line. Yeah, it checks out in several cases. If m is 1, then you run it if b equals... yeah. Should I have completed the square earlier? Whoops. It's good feedback. Okay, so I want arc cos of square root of that, because that's distance squared. Arc cos of b, add them together, see if it's bigger than p. That's a different approach, isn't it? I think we might be making a different mad picture that's wrong in a different way, but I'm having fun. Okay, so I want to write down large bracket time, and I have to type all of the letters wrong again, don't I? So this is b minus am becomes something like x tan p up here, and so the actual distance, let's write this down. Distance is, put mod signs around it or something. M squared, I've got feelings about that, haven't I? Because, yeah, I've got feelings about that as well, because if m is tan theta, then 1 plus m squared is sec squared. I think I'm just reinventing something really simple, aren't I? Whoops. Is it as simple as b minus am cos theta or something? Oh no, I'm an idiot. Oh no, I think I'm an idiot. Oh no, I think I'm an idiot. Is that just difference in the y coordinates but then projected with a cosine theta? Could be, couldn't it? Oh no. All of that, and then I think I've gone and done something stupid. Wait, let me piece it together. Mx. So this is a, b. Then this point up here is ma, b. So then find this distance. Find this distance? Why would you want that distance? I want this. Yeah, why would you want that long distance? B minus am. Why would you do the difference between the y and the x coordinates? No, this is a comma. I've written down the coordinates of this one wrong. Vertically upwards would be a comma ma. So then this thing down here is mod ma minus b for the length of this line. There's a theta in here, and so this is horizontal, this is vertical, this is sine theta. Oh no, this is the other one, and then project it opposite over hypotenuse. So sine of 90 minus this, so it is just this. Great, okay, let's write that in. I'm more happy with that. I should probably have written that down much faster. Let's put more signs around that because that's fun. Put cos p, so cos p in here. So gradient tan p and then cos p. Okay, right, but then that's one of the distances. So we want, how does this work? Is it arc cos in here? Plus arc cos of y. When is that equal to p? Ooh, not terrible. Terrible in a slightly different way. I mean, it's given us the same curve again, hasn't it? Keep getting the same answer, almost like maybe that's correct. Chat, has this been correct all along? The curve might be right. It was just so ugly the first time. Is this correct? This kind of boundary where biscuit inside here. Let's make this mobile.
Have we now done it 3 times and eventually discovered that getting the same answer 3 times? So we think balanced inside here, unbalanced outside. I don't know where this line goes. I've only discovered part of it this time, which is a bit sad, but hey. Let's turn on that one. Balanced. I mean, it is balanced if we put it here. It's balanced around here as well because it includes the centre. I think this journey of discovery may have reached the point where, yeah, so if I just have more plus minus signs around here somewhere. Yeah, putting the ones that correspond to B as well. I don't really know what that means, but if you put in the ones that correspond to B as well, then you get this shape, which looks suspiciously like an ellipse, doesn't it? So maybe this whole thing is just going to be an ellipse in the end. Back up here, if I put this plus minus sign in, then I get something that's more symmetric. It does feel a bit like that would balance. And over here, it doesn't because it doesn't even reach that side. Around here, it doesn't balance. So maybe the answer was ellipse all along. That would be a bit funny. Where are the foci? Yeah, exactly. Well, let's talk about this. Can I make that look like an ellipse? I reckon I probably can. By, rearranging and squaring. Yeah, I can always see how to do that, right? We'll always see. Actually, it'll be a bit of a mess, won't it? Divide this, move it over, square it, see what happens. Looks ellipsy to me. I'm going to do that live. Let's do that live in Desmos. This is a silly thing to do, but still. Divide it, you get the same thing. Blue for the new one. Confused itself about 10p, but that's going to go away in a second, I think. Move that onto the left, and move the other thing onto the right. Never do algebra live in Desmos. It will go wrong, and you won't be able to you won't be able to take it back. Squaring is a good idea. I mean, I don't believe in most of the ellipse because most of it's outside this range. And really, I only want a bit that's kind of inside the range. Outside here is going to fall off the outside of this shape. I'll add that in a second. And then this is looking a bit like an ellipse, isn't it? Because especially when I put plus y squared over here. Now that's looking quite a lot like an ellipse. And then the foci would be, I can't remember how to work out the foci of an ellipse given information about its major and minor axes, but there you go. It's definitely got something going on there, hasn't it? So then as p changes, it's just going to give us different values. Yeah, my intuition was that it should be, there's nothing over here because over here, no matter how far you reach, you can't get. Over here, you just can't reach both sides at once. Okay. Well, okay, we've reached some answer that it's an ellipse then, which is nice. So, based on the algebra that we were doing just before the tea break, looks good. I think we got there. Let's delete everything from our second approach, but it was doing the second approach that gave us the same answer again. I should probably reset. Oh gosh, are these arc causes secretly like a different way of writing an ellipse by adding two lengths together? Oh goodness, I think they might be. We've discovered other ways of writing ellipses. We may have done it, chat. We may be there. Kind of zone of safety is near here and includes, I wouldn't have guessed this at all, includes some points quite far away over here. Where you think, is that balancing? Is that balancing? So the way I can check that it's balancing, or try to convince you that it's balancing, is to draw in, and this is going to be a bit nasty, but I want to try and draw in that kind of region that we've been talking about. I've got 5 minutes on the clock, I think. We're going to try and draw this in to just demonstrate this. We have got quite a lot of stuff in this Desmos at the moment, but we're going to make the most of it. Let's go. So first I'd like to mark in that outside point, which from doing this calculation a few times now, I think is over here somewhere. There it is. And I'd like to mark in that point where we might not be critical, so this is a little bit tough. I need to solve I need to solve this equation, not that one, this equation at the same time as the equation for the circle. Never do your algebra live in Desmos, it's not a good idea at all.
things will go wrong. So you need to solve these simultaneous equations. Desmos is quite good for this. Look, it along the way draws. It's now describing two values of x. So it's drawing these two values of x. So I just need to. Well, ideally, I think I want this number for the solution to this. That's a little bit awkward. I mean, it's a quadratic equation. Desmos doesn't have a solve command, so you sort of have to just do it, which we've done once already on the stream, and I fear we are about to do again, because I'm going to try and write down a quadratic. Never do your equations live in Desmos. Why am I doing it like this? But never mind. And oh my goodness, that's quite a good graph, isn't it? Along the way, you get all sorts of nonsense, which is, I guess, part of the fun of doing algebra live in Desmos. The thing is, I've got to type the final result anyway, and then you get this nice check. This plot contains fine detail that has not been resolved. That is because I can't square live in Desmos. Never do algebra live in Desmos. There you go, back down to the same two numbers that we had before, but now it's formatted as a quadratic. Throw that away. Write down your solutions to your quadratic. Yeah, this makes sense. This is a good idea. So b squared would be, in this case, a squared minus, and then forget the 4, sec p squared for ac. We've gone full chaos here just to wrap up the show, but that is how we do things. I want all of that. It's not happy with me because of, I think, brackets. It's really not happy with me. Why are you so unhappy with me, Desmos? Was it the space? Do you not like spaces? I put 1 here, are you happy? Yeah, you're happy there. Not happy with that. P, a strange number. That's all right. Why are you giving me this undefined stuff in here? Would you like it if I simplified my... Talking to Desmos, sorry, would Desmos like it if I simplified this? No, it got really unhappy as soon as I did that. Why are you so unhappy, Desmos? Let me do sec p, but as soon as I square it, it's unhappy. Is it imaginary? Maybe it's unhappy because it's an imaginary root. Because I am doing something stupid. Yeah, probably that. Thanks, Maths222. You've done it in 3D. Great. I missed your chat message, but also your chat message. Yeah, maybe it's just telling me this root is imaginary. Why would the root be imaginary? I know it's 2 real numbers. Here are the red things. Running out of time. Minus b plus minus b squared minus 4ac. There's a 2 in here as well. Is that it? No. Plus. That's a number. Is it this number here? No. Getting closer though. Oh, that's a coefficient of x. Oh dear. That's all coefficient of x. So that should all be in here. Okay, I can't solve quadratics live in Desmos. News of the day, I guess. Yeah, it's supposed to be one of these things, isn't it? 2 tan pb. That's all coefficient of b. And then this thing is just supposed to be a squared plus b squared. Yeah, so that's the leading coefficient, and then this thing inside here should be a squared plus b squared minus 1. This is a great Desmos demo. Very pleased with this. It's giving me 1.41, which is still not the right value. Welcome back to Chill Maths on Twitch, where I'm desperately trying to write out some equations. All I wanted was to write down the solution to the quadratic. Is this not a factor of 2? Yes, it is. Well, that's not helping, is it? A plus tan pb, because that's the coefficient. Tan pb, sec squared. I might have to abandon this in a second again, because we've hit 4 o'clock. Plus or minus b squared minus 4, 8 minus A, C. Not happy. This should be here as well. I think I may have tried to do too much all at once with no success. Did the B get squared? Possibly not. No, it hasn't. Thank you. Yes, we did it. Thank you, Nstucky. Oh, you fixed my quadratic formula. I can normally do quadratic formulas, but not live onto it, it turns out. That is the x coordinate I wanted. We're going to give that a name. That's this. Is that. ID is xd times tan p. There we go. We're going to show where xd, yd is, and I feel like we've now got that point there. Good, turn off the red. Excellent stuff. We've got green over here. We've got, for some reason, this is a mobile point, which I don't love, which is just going to be that xa is equal to this number. And then I've got 2 points that I'm interested in. I think I sort of want to do this with a polynomial, so I sort of regret a lot of things that a lot of choices that I've made, but let's go for it. Which is the xc, I want to put the minus sign in here. And yc should be the y coordinates of that point, which is then xc tan p. And finally, for my last trick, so let's just check that c is in the right place as well. That's perfect. And xb for the last point, just trying to write down the coordinates of all of these points clumsily as you like. Let's check that b is in the right place. Oh, yd is just 0. Could have saved myself some work there. xb, I think I want the minus sign in there. There we go, good. Yep, that's the intersection with the circle. So now I just want to draw the polygon. And this is going to look amazing. So it's going to be worth it. That's not really true, but we'll do our best. Polygon comes back down to xc, goes out to yc, and then comes back down to x. Oh my goodness, this is a bit of a mess, isn't it? xb. I can't remember why I named them in that order. There is the polygon that I wanted. Excellent stuff. So now what we can do is look at that polygon that supports the biscuit as it moves around. And say that inside this region of stability, you get, I love that it's highlighted this red edge as well, you get some intersection with the edges, and the convex hull of those gives you this kind of stable region where the centre of mass is somewhere inside that region that's been supported by the edges. But if you move outside this ellipse region, if you move too far, you don't get any intersections. And sometimes you get intersections just down here. No, that's not what I wanted it to do at all. That looks quite stable to me. That looks quite stable. It's almost what I wanted. It's almost what I wanted. And that looks unstable because now the centre of mass has moved outside that region. I've got an unanswered question, I think, which is that these ones definitely look okay. So it's all of the contact is over here, but the centre of mass is over there. I've got some cases that I'm worried about where I think that looks stable. I think that looks stable. So I've gone back to not believing my solution with this lovely ellipse marked in blue, because that looks stable to me. So I think more research required. But we've captured some of it. Some of this is good. Kind of around here, where it really feels like that is the boundary between whether or not you're supported or unsupported. Around here, if I move it, I'm inside, no, I'm outside. I'm crossing the red line, I'm not crossing the red line. So, more research needed. Some of this I believe, some of this I don't. I mean, that just looks stable, right? Which way is it going to fall? It's supported by all these lovely points. So it's maybe from here, does it just go straight over? Oh yeah, straight over from here.
Okay, new working hypothesis. Homework, I think. Extra bit of blue line. Well, I think this little region should actually be considered safe. I don't know why, but I think some of my algebra just goes wrong. Up here, terrible, you can't even reach down there, reach that point. In here, seems fine to me. Yeah. There's this little, not triangle, right, but it's got two straight sides and an ellipse side. Well, I think actually that's safe, for reasons I don't understand from the geometry that we've been trying to do. And I think there might be another one down here somewhere. A similar region where actually everything's fine. Parallel to, oh gosh, parallel to tan theta. I reckon there's a little region over here that's actually safe. Like if I put it right here, that looks fine. Supported region, balance, nice. That, no chance, terrible. Gone. Gone. And so we wouldn't have seen this before, because if we're in the right angle case, that little region doesn't exist. A good place to see this will be over here. Well, I think that's stable, 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 and there's some other barrier over here to say whether or not you meet these things. Okay, cool. More research needed. I'm going to call it a day there, though. So thanks for joining in. If you want to do this problem at home, well, the question is as follows. You have a circle, and its intersections with two lines, the x-axis and this line y equals tan theta, y equals tan theta x. And the question is whether or not the centre of the circle lies within the polygon formed by the four intersection points with those lines. I think we've got some well, our current solution is not correct. Not quite correct. Almost correct, but not quite. Right, next time with the measuring angles. Yep, good luck everyone. If in doubt, go to 3D. Should we have a look at this 3D plot that someone Maths Teacher did? Yeah, oh, that's nice. Yeah, they've made a kind of circle and wedgie thing going on, so you can visualize this in 3D. link in Twitch chat. Right, cool. I will see you next week, I think. Probably. Checks calendar. Yeah, sure. What else am I doing? See you next week for more chill maths. Until then, have a nice rest of your weekend. nStucky is going to be live at some point this afternoon. So if you want to follow nStucky, there they are in chat. I don't know what sort of content they're doing. Are you reading biographies again, nStucky? Is that the plan for today? Oh, I don't know if they're here. Maybe they don't have a plan. You don't have a plan. An hour or two. Okay, in an hour or two, maybe some of you will be over in nStucky's chat. I will maybe see you over there. Right, good. Okay, take care. Have a good weekend. How do I stop? Ah, no, I know this button. Bye.